This is section 8.2, areas in the plane. Fill in the blanks with the setup of the problem. The work for the integration is already filled out. Students will be able to find the area between two curves analytically and using a calculator. So here's the whole concept. Let's say you have an area below this curve right here, or this line. And let's say we're up here at y equals 40. And then we have a line here at, let's say, y equals 10, and we want to find the area in between. Well, what you can do is you can take all of this 40 right here, and we can end up minusing out the area under the 10. So when you minus that out, you end up with area in between. So we're going to take the top area, all of it, minus the bottom area. And that's the whole concept, is top minus bottom. So here's the setup to this problem that we have here. Now we have 2x squared is this parabola, and x to the fourth is the curve that's below the parabola the entire time. Now we're integrating from -2 to 2. So from -2 to 2, the top equation, the one above, is the 2x squared. And we're going to subtract out the area below. Now, it doesn't matter that we go from positive to negative area. That all works itself out. We actually don't have to worry about that. So as long as you take top minus bottom, that's it. That's all you have to do. So there's the top function minus the bottom function, which is the x to the fourth minus 2x squared dx. Now, that's the integral from -2 to 2 of, if you have 2x squared minus a -2x squared, that's actually going to be 4x squared. So we have 4x squared and then minus x to the fourth dx. But these are both even function. All the powers are even. So instead of integrating from -2 to 2, one option, you don't have to do this, is to just integrate from 0 to 2 of top minus bottom, and then just double that answer. So we're doubling, integrating from 0 to 2. By this point in the class, I expect you to know how to do the integral, especially the integral of a polynomial. So I've written out the work for it, and the answer ends up being 128/15. Let's set this one up. And the difference between the one we did before and this one is that the top and the bottom function are going to trade places. So from -2 to -1, we're going to integrate from -2 to -1. The line is the top function, and the line is -x plus 2. There's top minus. The bottom function is the curve, so 4 minus x squared dx. So we're going to add that to, now we're going to go from -1 to 2. We're going to go until they switch places again. So now -1 to 2, the top function now is the curve, so 4 minus x squared. And we're going to subtract the bottom function now, which now is the line, so -x plus 2. Then they trade one more time from 2 to 3. So from 2 to 3, they switch back, and now the top function is the line. So we have -x plus 2 minus, and then 4 minus x squared, 4 minus x squared dx. And then I've written out the rest. The answer ends up being 49/6. Find the area of the regions enclosed by the line. Now the difference between this one is now it's much easier to write x equals y squared. So instead of having a y equals, like we mostly have, we see a lot of y equals. Now it'd be much easier to have an x equals. And let's open up a calculator for this. Let's slide that over. So x equals y squared. I actually know what that looks like. That's like y equals x squared, except going off to the right. So this is actually x equals y squared, this parabola right here. And then we have x is equal to 3 minus 2 y squared. So I actually know what that one looks like too. It's 3 to the right, because if you plug 0 in for y, you get 3 to the right, 1, 2, 3 to the right. And then this -2y squared, normally a -a would mean the parabola is opening down. But if it's a -a with the y squared, that means this parabola is opening to the left rather than opening to the right. So that's kind of roughly what this graph looks like. But we can do this using parametric. So we're going to let's clear this. Let's go mode and we're going to do parametric. Let's go to y equals, and the x equals is y squared, so it's actually going to be t squared in this case. But the y is going to be the t values. And then we have x is equal to 3 minus 2t squared, and then the y is going to be, again, the t values. So if we go, let's go zoom 6, there's the top part of this parabola. And the reason it's not graphing the whole thing is because this is really set up for trig values. This is 0 to 2 pi. So let's just go from like -10 to 10 with this and see if it just fills the window. And if it doesn't, we just go from -20 to 20. So let's graph. And now we're going to see that full parabola. And then here's the other one right here. So now we want to know where these two are intersecting. So we want to know, where does y squared equal 3 minus 2y squared? So if we add the 2y squared over, we get 3y squared is 3. Y squared is equal to 1. So y is equal to plus or minus 1. Now, instead of integrating top minus bottom, we can't do top minus bottom because that's really the same function. So now we're going to do right minus left. So we have the right function minus the left function. But instead of integrating on the x now, we're integrating on the y. So we're going to integrate from, now these are even, kind of even functions, but now it's symmetric over the x-axis. So what we can do is we can double and go from 0 to 1 instead of going from -1 to 1. Now the right function is 3 minus 2y squared, and the left function is y squared dy. And here's where we get the 2 integral from 0 to 1 of 3 minus 3y squared dy. And then we're off and running, and the value ends up being 4. Let f and g be the functions defined by. Now this is a calculator free response question that's been released. So we have a function, and g of x is this one. Let R and S be the two regions enclosed by the graphs of f and g shown in the figure above or down here. Find the sum of the areas of region R and S. Now we can use a calculator for this. So let's get out of this mode. We're going to go to y equals, clear all this stuff. And we're going to go 1 plus x plus e to the, holy cow, what an equation, huh? Minus 2x, and then we have x to the 4th minus 6.5x squared. Oh, shoot. Let's try that again. X to the 4th, arrow over, minus 6.5x squared plus 6x plus 2. And you can go over and you can make this like a bold line so you can tell the difference. If you just press enter on that right there. Now we go 0 to, we can go window, 0, oh, not again. There we go. 0 to 2, and then we can go from by 1, 0 to 4, and graph like this. Graph. So the f of x is this little curve right here, and then this one is actually the x to the 4th. So now we want to find this intersection point, because that's when this top line, let's see, this was g of x, so that ends up being g of x. This is f of x. Then this is f of x, and this is g of x. So we want to integrate from 0 to this intersection point. Let's find that. Calculate intersection, enter, right there roughly. 1.032. 1.032. And I've seen this before too on rubrics where they're going to go A is equal to 1.0328319, and they're going from 0 to a, and we're going to do g of x minus f of x dx, and then plus a to 2 of f of x minus g of x, and that's what we're going to have to do in the calculator right there. So let's go to the calculator, and we got, we're going to go math number 9, and we're going from not 5, 0 to x of, we actually want y2 minus y1. So we're going to go variables, y2, and we're going to go minus variables, y1 with respect to x. And then we're going to add that to math number 9. Now we're going from x to an x value of 2. And we want variables, y1, and then minus variables, y2 with respect to x. And we finally get our answer. The answer is 2.004.